Continuing on, for example 2, sketch the graph of the piecewise function. Now, piecewise functions are slightly different graphs. They really consist of pieces of the function, not the entire function. So let me elaborate. If I wanted to graph this, I would say x squared plus 2. Well, I could make a list if I really want. Where does that equal 0 at 0? Right? A point above it and a point below it. Unless you picked it up already, this is a parabola shifted up 2 units, not a big deal. And plug in 0, I'll get a 2. Plug in 1, I'll get a 3. Plug in negative 1, I'll get a 3. 0, 2. 1, 3. And negative 1, 3. This is the entire parabola. But I noticed, again, I'm going to erase this. I notice there's a condition on it. The condition states x has to be less than or equal to 1. Since this is the x-axis, you have two options. You go to x equal 1, included, and when it says x is less than or equal to 1, you only want the left portion of that. You erase that part. That's one way of doing it. Or, you could say, well, let me figure out what this point is. If x equal 1, I have 1 in there. 1 plus 2 is 3. And you could start this way. Of course, first you need to recognize how the graph looks like. And you could say, well, let's, oops, the last here. Good. You could say, this graph starts at 1, 3. And then you could say, well, okay, now since x is less than 1, let me pick 0, 0, 2, and continue the graph that way. Whatever works. This right here is actually a straight line. So the line really runs from 1, 2, 3, rise 1, run 1. The line looks like that. Here on this graph, 0, 1, 2, 3, run 1 up, 1 to the right. The line looks like this. But you really don't want all of that line. If you really look closely, you'll notice it says x is greater than 1. If x equal 1, y would be 4. So the point 1, 2, 3, 4 is not included, if you notice. And when it says x is greater than, isn't x greater than, they're talking about the right side? So they're talking about that piece of the line. So you could draw the whole line if this is confusing you in the beginning, and then erase the other part. Or you could just get straight at it, whatever works. Another example, so let me show you really quick. If I look at y equal x cubed minus 1. Well, y equal x cubed minus 1, x cubed looks like this. The minus 1, so when I put 0 in there, I'll get a negative 1. The graph looks like this. And the graph of y equal 3, I know how that looks. A horizontal line. But they have restriction. Here it says, if x is excuse me, if x is between negative 1 and 1. If x equal negative 1, wouldn't that be negative 2? And if x equals a 1, isn't that a 0? So negative 1 is right there, and 1 is right there. They're talking about x being between. So remember, at 0, negative 1, the graph should continue on. But this is the only portion that we are interested in out of the cubic. We don't care about this part or this part. We only care about x being between negative 1 and 1. Now, when I get to the line, doesn't that mean that when x is greater than 1 or x is less than negative 1? Well, x equal 1, y equal a 3. X equal 1, y equal 1, 2, 3. Not included. Should shift that down a bit here. I can fix that easily. If I shift that 1 unit down, everything matches. There we go. So when you say x equal 1, 1, 2, 3, not included, when you say x is greater than 1, isn't that shading to the right? And if x equal negative 1, y equals a 3 no matter what. Negative 1, 1, 2, 3, not included, and you shade to the left. There it is. So that's how these graphs look like. Piecewise function or split functions, some books call them. This book calls them piecewise. That's pieces of graphs. Here we have 3 pieces. We have a piece of a straight line. Well, 0 is the break off for that. Put a 0 in there, that's 0. The origin is the break off. Doesn't this line has a slope of 2? You rise 2 and you run 1. The line should run infinitely. But if you really pay attention, you'll notice 0, 0 is included. And the line x is less than, isn't that the left side of the line? Nothing on the right. The piece in between, that's a parabola, upside down parabola. At 0, right, you are at 4. 0, 1, 2, 3, 4, not included. And at 2, if I put a 2 in there, isn't that at 0? That's included. And doesn't a parabola look like this? And how about this line? Well, that's a straight line. At 2, if I put a 2 in, I'll get a 0. 1, 2, 0, not included. And with a slope of 1, rise 1, run 1. So which piece of the line am I going to get? The upper half or the bottom half? When it says x is greater than, doesn't that mean that you shade to the right and you forget the left? And keep in mind, this is a function. When you're done, it should look like the graph of a function. And how about if we wanted to look at part D? Part D, we have to split ourselves. We have to say k of x is going to equal absolute value. If x is bigger than or equal to 0, I don't need the absolute value. That would be x plus x, which is 2x. And if x is less than or equal to 0, then that absolute value will be a negative x, right? Plus x, that would be 0. So this will look like y equal 2x if x is bigger than or equal to 0. At 0, I am at 0. Rise 2, run 1. X is greater than or equal, you shade to the right, and you make sure that you include that point. This should have been strictly less than 0. If x is less than 0, y equals 0. Well, y equals 0 is a horizontal line, but it's only to the left of 0. Now, if you remember, I was going to go over that last class meeting in the last video of section 2.1, but it doesn't come up until now. If you recall, to determine whether you have a function, you look at the x values. 1, 2, 1. It repeats. Since 1 repeats and those are distinct points, this is not a function. If I plot these points, 1, 2, 2, 3, and 1, 5. Do you notice x equal 1? At x equal 1, graphically, do you see that it crosses twice? So graphically, if I draw a vertical line and it crosses more than once, that means there are 2 different values associated with that point. That indicates it's not a function. This was example 1c from the previous section, section 2.1. So if I look at this definition, a vertical line test, it says the graph of a relation represents a function if no vertical line intersects its graph more than once, or if every vertical line intersects its graph at most once. Given a graph, I'm asking you if this is a function or not. You draw a vertical line. If it crosses more than once, automatically not a function. And even though some places you might find that this satisfies the vertical line test, but you're looking for one exception, not a function. And if I draw a line right there, a vertical line that's 1x, it seems to have 3 values. This is not a function. And if I look at this line, no matter where I draw a vertical line, it will cross at most once. This is a function. And that's pretty much it for this section.